Now in chapter 4, we're going to be looking at switches and buttons and how to use them and how they operate. Now, a button is used in many different devices, but a button pretty much when you press it, it will allow the signal to flow, and when you release it, it will stop. That's what a button basically does. Now a switch works a little bit different. A switch will stay on. So many light switches or things like that, it will stay on when you click it and you have to physically go switch it off. So a button is just a temporary as you push down, and a switch will stay on. So let's look at the functions. So functions are basically to be able to switch current on or to allow current to flow. So a switch can either allow it to flow or stop the flow. So let's say, for instance, your lights at home. If you go switch it off, the current is not flowing to the lights. And when you switch it on, the current is flowing to the lights. Okay, now push buttons, we're going to talk about that a little bit. They come in remotes like you just saw, TV remotes, PlayStation remotes, even your keypad on your keyboard and things like that. Those are buttons. As you press it, it sends a signal, and when you release it, it stops. So we have created our own little push button. Now we've used these file binders as little push buttons. So what they do is when you press it, it makes contact and then it kind of bounces back up. Okay, so let's create our first circuit at the bottom of page 26. We need a push button and a light bulb. And we're going to connect our batteries. And then when I press the button, the light should come on. There we go. And when I leave the button, the light goes off. On, off, on, off. And that's a push button. Basically what's happening is as soon as I press it, and the electricity will then flow, or the current will flow through this file binder, and as soon as it touches that screw, it then flows to the light bulb, as you can see that there. And that is basically what a switch is or a button is. It allows the electricity or current to flow. Now, I've got two of these switches, and I would like to create a house alarm. So I've also got a buzzer. A buzzer is quite a nice component. It basically just buzzes and makes a really loud noise. So let's quickly hear what that sounds like. Now, a buzzer is polarity sensitive. So we want to make sure that we put the positive side on the positive and then the negative side on the negative. Now usually with our leads you want to use a bright color like orange or something like that, or red with our positive, so that we always know that that's the positive. So in this case our yellow is our positive and our green is our negative, and you can slightly hear it there. But if I take off this little piece of paper, it's going to be a lot louder. And that's a buzzer. There you can hear that's the buzzer. So we're going to use our buzzer as a little house alarm, and we're going to use our little push buttons as a trip or trigger switch under the carpet. So where we want to put it, and you'll notice that on page 27 there's a little diagram or a little picture that shows you we want by our front door. If somebody steps on the front door mat, it must press down on our button, and if somebody steps at our back door mat, they're also going to press down on a button, and we want the buzzer to sound so that we know somebody is by the front door or somebody is by the back door. So while we're sleeping, if somebody comes, then you can be aware of it. Okay, now option 1 is to connect the two switches in series. It means the one flows into the other one. So let's see if this is going to work. Let's create the circuit. So we need to move our batteries there. We're going to put in our switch over there, and we're going to put this one in over there. Okay, and then we're going to connect our buzzer. Now remember, our yellow is our positive, or your bright color will be your positive, and the other one will be your negative. So let's see if this works. So now let's say I'm busy sleeping, somebody walks to the front door. Oh no, nothing happened. Somebody walks to the back door. Oh no, nothing happened. Let me just take off this tape that we can make sure we can hear it or not. Okay, now let's say I walk to both the front and the back door. Now it works. This is what we would call an AND function or an AND gate. It means that button 1 and button 2 need to be pressed for us to hear the buzzer. Is this going to work? No, unfortunately I don't think so. But let's look at the table at the bottom of page 27. If both are off, the buzzer will be off. If button 1 is on and button 2 is off, the buzzer will be off. If button 1 is off and button 2 is on, the buzzer will be off. And only when button 1 and button 2 are on will the buzzer sound. And this is a AND gate or AND function. Now, notice when in electronics, when we refer to something as off, we say 0. And if we refer to something as on, we will say a 1. And that's what's in that little table. So this is not quite going to work for our house alarm. Let's see if we have another option of how to connect them. What if we put the buttons in parallel? Let's give this a try. So all we need to do is we need to move that there, and we need to move our source there, our battery negative there. Now this means that if I press this button, the negative will flow to the buzzer, or if I press this button, the negative would flow to the button or to the buzzer. So let's give it a test. If somebody comes to my front door, it works. If somebody comes to my back door, it works as well. So this is exactly what we want for our alarm. If somebody comes to the front, we'll hear them. At the back, we'll also hear them. And this is what we want. So this is called an OR function. If button 1 is pressed or button 2 is pressed, it will go on. But what would happen if both are pressed? It will be on. Okay, let's look at that table in the middle of page 28. If both are off, the buzzer will be off. If 1 is on, it will go. Or if 2 is on, it will sound. Or if both of them are on, it will still sound. So this is our OR function, and this is exactly what we would want for our house. Now you are welcome to go test it, build a little model house for yourself if you want to, and actually put a little carpet there and give it a test. But this would be the circuit that you would use. It's the two buttons in parallel creating an OR function. Either button 1 or button 2 should be on for it to sound. Okay, now let's go look at our next activity. In this activity, we'll be using what we call a SPST. Now, SPST stands for single pole, single throw. So these are switches, a single pole with a single throw. Now, at the bottom of page 28, you'll notice that it is on when it is switched to the right. It means that the two legs are connecting with that little wire by the switch. And it is off when it's to the left. It means there's no more connection. The current cannot flow there anymore. So the pole is usually the middle leg, or in this case, the left leg. And the throw would be on the right, which is the right leg. So that is a single pole, single throw. That's what SPST stands for. Now let's quickly control a fan with a single pole and a single throw. So let's connect our motor back up. There our motor is connected. Let's connect our motor to our snack board. So we've got our connections there. Now we're going to be using a paper clip as a switch because we leave it in position and it stays on. It's not like the push button that bounces back. So the paper clip will actually stay in position. Now our pole is usually where we allow our current to come in. So let's put our pole on. So now this means the switch is not switched, it's off. So if you refer back to page 28, this would be the switch being on the left. Now if I move the switch to the right, it would go and actually make contact with the motor and the current would flow through the switch making contact. So this will be on. So this is my pole, this is my throw. So single pole, single throw. So let me take off my pole and my throw, and let's just put it on the pole and not on the throw. Nothing will happen. As soon as I put it on the pole and the throw, then it will actually come on. So that makes sense. So that's a single pole, single throw. Now, what would happen if I were to bring in another single pole, single throw, another switch? What could we do? Now, if you are working in a workstation or in a workshop, you many times have to use a grinder or a machine with a motor or a blade, and that's quite dangerous to operate with those things. So what happens is you get a switch at the wall and you get a switch on your grinder or on your drill or on your physical bench saw or whatever it is you have in your workshop. Now, if these two switches are connected in option 1, is it going to work? Let's quickly see. So what we want to avoid is we want to avoid both of them or the grinder coming on if any of them are switched on. So let's see. So option 1 says we're going to connect them in parallel. Let's just switch off our circuit so we can quickly do our connections. So that says that if both are connected in parallel like that, okay, and now let's give it a test. Okay, so the grinder is on. Now I switch off the grinder by the remote or by the handle on the actual grinder. Oh no, it still stays on. So that means I need to go switch it off at the wall as well. So let's say I work into the workshop and now I switch on the plug at the wall and suddenly the grinder comes on. That could be very dangerous because it could be lying next to a computer, or it could be lying next to somebody's hand and it suddenly cuts their hand. So that's a very dangerous thing. So we are definitely not going to do this option. What is this option called? This option is the OR function. Either switch 1 or switch 2 needs to be on and the motor will turn. So this is ideally not what we want to use. So the OR function is not going to work for this specific case. Let's look at option 2. Option 2 is the AND function, which means we connect the switches in series. So what we're going to do is we're going to move our terminal to the side and we're going to leave that switch there. And we're going to move this switch to this side here. Now I'm going to leave it off for now. Now let's look at our little table on top of page 30. Now that table says that if both switches are off, both switches are 0 off, the motor will be off. If switch 1 is on, the motor will still be off. If switch 1 is off and switch 2 is on, the motor will still be off. But if both switches are on, the motor will be on. And this is exactly what we want. We want to switch the motor on at the wall or the grinder on at the wall and physically on the grinder itself for protection so that it doesn't just randomly come on. So go ahead, play around with this circuit, have fun, see if you can create some of your own circuits with this one. Now on the middle of page 30, you'll see that we have got a single pole double throw switch. So what we're going to be doing is we're going to use this very same paper clip. We're going to just use one of them and we're going to use it to throw the current either to the left or to the right. Now if you look at the diagram carefully, when the switch is to the left, the pole and the left leg are connected. When the switch is to the right, the pole and the right leg are connected. So we have a single pole with 2 throws, hence the name single pole double throw. So let's create a car indicator with our flashing LEDs. Now quickly go to page 31 and at the top of page 31 we're going to make that circuit. Okay, so we need to remove our motor. We need to get our flashing LEDs. We'll need a male wire so that we can connect these 2 sides. So I think the most important thing to notice is that the positive is on the left and we use the male to male to extend the positive all the way to the right as well. Okay, so now we're going to connect this with our paper clip. So we want our paper clip to be in the middle, so we're going to put our pole in the middle and we're going to have our pole there. So the paper clip can either throw negative this way or it can throw negative that way. You see that? Now let's connect our bright or flashing LEDs, sorry. Now our flashing LEDs, we need to remember the polarity of it. So positive needs to be by positive and negative by negative. And there you'll see that one will start working because this is connected. But now this side, we need to turn it around. Remember the positive is going to follow my green wire to the side here and it's going to be connected there. So now I'm indicating to the left. And if I were to switch this around to that side, I'm indicating to the right. Now, if your batteries are a bit fuller charged or a bit newer, you'll have a nicer flash and it'll be a lot brighter. But that's the effect that we want to get. So a single pole can throw it to either side. Now that is a single pole double throw switch. And that concludes the switches and buttons. Now, I want you to take some time, go have fun, experiment with your snack board. You've got a lot of things, you've got motors, you've got buzzers, you've got buttons and switches and bulbs and flashing lights. And I want you to go have fun, play around with the circuits, create your own circuits, use your multimeter to measure, see if you can understand what is happening where, use volts, use amps, use ohms, and just go have fun and measure a whole bunch of different circuits and create different circuits and have a lot of fun with your snack board. Now, in conclusion, I just want to end off with one last character tip, and then we're finished with this course. So just like a switch can let power flow or not flow, we can choose what we say to others. We can make that switch. We need to choose to flip the switch and not say bad things to the people around us. Let's rather speak life. So if somebody upsets you, instead of just switching over and being angry and saying things that you don't really mean, rather switch off, stay calm, and think clearly before you speak. We'll see you guys in Module 1. We'll be learning how to build our own little gear car. We'll be learning how to create our own little circuits with transistors, with LDRs, light sensors. We'll learn with thermistors, and we'll be creating a whole bunch of fun projects in Module 1. We'll see you there.